What we're going to work on in this video is how to factor binomials. By binomials, we mean polynomials with two terms. Now on the left, we have all the formulas we use to factor binomials. Now the key thing to see is that each one of these formulas is separated by a different exponent. Usually we look at the leading exponent in the first term and the plus or minus that's in the middle. Okay. Now, when we look at this problem over here to the right, we can see that the exponent is 2, and this is separated by a subtraction. So we're going to be using this formula over here for this first problem. Now, let's put this over here and see if we can do pattern matching. So we have a squared minus b squared is equal to a minus b, a plus b. Now we can see that a squared is equal to 4x squared, and we can see that b squared is equal to 4/9 squared, and we can also see that this subtraction is just ignored. It's basically eaten up by the formula. So the b will always be the positive second term. Now, let's line these up horizontally. A squared is equal to 4x squared, and b squared is equal to 9y squared. Now, our goal is to find a and b so we can put it in this formula and finish this equation, finish this problem. Now, to get rid of the square, I square root both sides. Anything you do to one side, you do to the other. Now, the nice thing about this is that this square root will cancel out that square. This square root cancels out that square. And you can see that we get a is equal to, let's use that, square root of 4. Now, what the square root will do is we'll divide that 2 by 2. So anytime we use a square formula to find a or b, we're always going to divide the exponent by 2. Whenever we use these bottom two, we'll divide the exponent by 3, but we haven't gotten there yet. So we can see that a is equal to 2x, and we can see that b is equal to square root of 9y squared, also divided by 2. And we can see that b is equal to 3y. Now, most people don't do this explicitly. They'll just do it in their head. When they see this original problem, they'll just go square root of 4 is 2. 2 divided by 2 is 1. So a is equal to 2x. Same thing here. That'll be square root of 9 is 3. And then 2 divided by 2 is 1. So I get 3y. So most people will go directly from here to here. Now, what we're saying, if we look at our original problem, we're saying that this is equal to a minus b. So here's a, here's b, a plus b. Okay. And if we wanted to double check it, we could by foiling. We could see that this times this is 4x squared. This times this is 6xy. This times this is minus 6xy. And that times that is plus 9y squared. Now, these 6xy's will cancel. I'm sorry, not plus. This should be a minus. And we'll see that we'll get a 4x squared minus 9y squared. So we'll see that this really is equal to that. Now, when we do this problem over here, what we're looking at is that square and that plus. And what that tells me is that we're going to be using this formula here, meaning that this is prime. Now, let's talk about what prime means. If I ask you to factor 6, you would say, what times what is equal to 6? Well, 2 times 3 is equal to 6. Now, if I was to ask you the same question to factor 7, you would tell me, oh, you can't factor it. And the reason why you can't factor it is because it's prime. So this is not factorable because this is prime. Sometimes books will say not factorable, but in our book it says prime. Now in this problem, we're going to first check that there is no greatest common factor, and we can see that indeed there is no GCF. So the next thing we want to do is we want to then look at the exponent and look at the operator in between. And we can see that this is a cube and a minus problem. Okay. Now, let's put the a cubed minus b cubed underneath here. And let's see if we can sort of understand what a and b is going to be equal to. Now, first we'll see that a cubed is equal to 8x cubed. And we can see that b cubed is equal to 125. Now let's remember our cube chart. The cube chart is 1 cubed is equal to 1 times 1 times 1, which is equal to 1. 2 cubed is equal to 2 times 2 times 2. 4 times 2 is equal to 8. 3 cubed is equal to 3 times 3 times 3. 9 times 3 is equal to 27. 4 cubed is equal to 4 times 4 times 4. 16 times 4 is 64. And 5 cubed is equal to 5 times 5 times 5. 25 times 5. So if you have 5 quarters, you have $1.25. Now we can rewrite 8 cubed to be a cubed is equal to 2 cubed, x cubed. And if we wanted to, we can pull out the cubed to show that, well, if we do the same thing on both sides and got rid of the cube on both sides, we would get a is equal to 2x. Now, there's a lot of pain going from here to here. What I usually tell my students is, look at the cube chart when you're using these two formulas. If you see an 8, think 2. And what you want to do to go from a cubed to x is divide the exponent by 3. When you use this formula, you divide the exponent by 2 because we're square rooting. Over here, we're cube rooting, so we are dividing the exponent by 3 for these two formulas. So if we're to sort of use that rule over here, we can see that when I see 125, I should think 5. Now, let's put that back into here. So we can see that a cubed minus b cubed is equal to a minus b, a squared plus ab plus b squared. So let's put in 2x and 5 everywhere we see an a and a b, and you'll get 2x minus 5. And then remember, when we do a substitution, we need to use parentheses. 2x times 5 plus 5 squared. Now, the important thing about the parentheses is that when we have something like this, let's remind ourselves, when I have 2x squared, there's a multiplication in between the 2 and the x. So I actually have to distribute the square to both the 2 and the x, and I get 4x squared. So now I get 2x minus 5, 4x squared plus 10x plus 25, and then that's my answer. Now, understand that even though this is a trinomial, it's prime. So if you try to factor that, it just won't work out. So once you plug your a and b back into this formula and sort of clean it up, we're done. So let's try this again. First, we'll check to see if there's a GCF. There is none, right? The next thing we'll do is we will look at the exponent and we'll look at the operator. Usually we're looking at the exponent of the leading term. So let's look over here. What we want to match it with is this over here, the cube and the plus. And if we write down the cube chart again, and we go 1 cubed is equal to 1, 2 cubed is equal to 8, 3 cubed is equal to 27, 4 cubed is equal to 64, 5 cubed is equal to 125. We can see that when we see 64, we should think 4. And then we should divide our exponent by a 3. So remember, we divide these exponents by 3 and this one by 2 when we're trying to find a or b. So we get a is equal to 4x, and we get b is equal to y cubed divided by 3. So now we get b is equal to y. Let's plug it into this formula. We'll write it down first just to give us a guideline. Okay, remember a is equal to 4x and b is equal to y. So let's just plug it in. 4x plus y, 4x squared minus 4x times y plus y squared. Now let's clean this up a little bit. Remember that 4x squared, there's a multiplication between, equals 4 squared x squared is equal to 16x squared. So nothing is happening here, but we do have to turn that into 16x squared minus 4xy plus y squared. Remember, this is prime, so we can't factor it any further. So let's make sure we understand that the first thing we always do when we factor is look for a GCF. Now, I mentioned this in the other problems, but since we were learning how to do these problems, they didn't have a GCF. This one does. So if you ask yourself what number divides into the 12 and the 75, 3 does. And if you say if both of these have an x, which one has the smallest exponent? Well, it's that one. So we can pull out a 3x for a GCF. At this point, this is when we look at the operator and the exponent to determine which formula we're going to use. We are not going to look at the original problem, but the one that has the GCF pulled out. So we're not going to use this formula. We're going to use this formula because once we pull out the GCF, the square and the minus matches it. So now this will turn into 3x. We're going to take the square root of the 4 and the square root of the 5. And we're done. And the key point here is that always pull out the GCF before determining which of these formulas you're going to use. Now, let's look at a boutique problem. So let's look at a problem that looks almost like this. Okay, so if we look at something that looks like 81x squared minus 16. So instead of a 4, I'm going to use a square. The way we find a is we take the square root of the coefficient and we divide the exponent by 2. For the b, we do the same thing. So we get a is equal to 9x, b is equal to 4, and we're going to be using the a squared minus b squared is equal to a minus b, a plus b formula. So if we start all over again and we say factor 81x squared minus 16, this is our a squared minus b squared. This will be equal to 9x minus 4, 9x plus 4. Okay, now the key thing is that this worked when this was a 2. It'll also work when this is a 4, but we have to be careful. When we try to compute our a and b, okay, a is still going to be equal to the square root of 81, and then we're going to divide that 4 by 2, just like we did over here, so that we'll get a is equal to 9x squared. With b, we're going to do the same thing, same rules apply. So we're going to use this formula again, a squared minus b squared is equal to a minus b, a plus b, except this time the a has a 9x squared there. So we'll get 9x squared minus 4, 9x squared plus 4. Now the trick to this problem is that this is still factorable, this right here. See, I got a square and a minus, so I can use this a squared minus b squared formula again. And I can go 3x minus 2, 3x plus 2, right? I'm taking the square root of 9 and 4, and I'm dividing the exponent by 2. Now, this right here is prime. It's still part of the answer. It gets moved down. See, this times this is equal to that. In order for me to get the original problem, I need to multiply this times this, and then that whole thing times this. So think of this problem, it's similar to my asking you to factor 42. So if I ask you to factor 42, you'll probably start with 6 times 7. And you go, wow, 42 is equal to 6 times 7. I go, that's nice. Go all the way down to prime factors. And you'd say, well, 6 is equal to 2 times 3. Now, in order to get 42, you still have to bring down that 7, right? 42 is equal to this 2 times 3 times 7. Even though 7 is prime, it's still part of the factorization of 42. Okay, let's work on factoring a bunch of different problems. The first thing we want to do is we want to pull out the GCF. So over here, we can see that 8 divides into both terms. So 8 is my GCF. Once we pull out the GCF, we'll then look at the exponent and the sign to figure out which formula we're going to use. In this case, we're going to use the a cubed minus b cubed is equal to a minus b, a squared plus ab plus b squared problem. Remember, we always look at the version of the problem after you pull out the GCF to figure out what formula you're going to use. Now, in this case, we have to find out what the a and b is. So the a, well, let's go through our list of cubes. 1 cubed is equal to 1, 2 cubed is equal to 8, 3 cubed is equal to 27, 4 cubed is equal to 64, and 5 cubed is equal to 125. So when we see 8, we should think 2. So a is equal to 2, and then we're going to divide the exponent by 3. So this is equal to 2x. And in terms of b, whenever we see 1, we just use 1. And in all these problems, the b will always be a positive number. Now, let's plug it and chug it. Let's put these two things in that formula. So first, don't forget your GCF. And then you get 2x minus 1, 2x squared, plus 2x times 1, plus 1 squared. Now remember that you're going to distribute that square to both the 2 and the x. So we'll get 8, 2x minus 1, 2 squared is 4, 2x plus 1, and then we're done. We just stop here once we plug everything into the formula. Now, Over here, my GCF is x. Okay. Now, we don't use the original expression to figure out what formula to use. We always use the expression after we pulled out the GCF. In this case, it matters because we have a square and a minus, not a cube and a minus. We're going to use the square and the minus formula, which is a squared minus b squared is equal to a minus b, a plus b. So let's remember for this formula, a is equal to the square root of 64, x squared, and we're going to divide that exponent by 2. And then b is equal to square root of 1. So let's finish up a. A is equal to 8x. So we'll get x times 8x minus 1, 8x plus 1. And then we're done. Now, this problem over here is so easy it's hard. So this typically is the problem my students get wrong the most. The first thing we're going to do is we're going to pull out the GCF, which is x squared. And then we stop. Because we have a x with the exponent of 1, there's no factoring anymore. It's done. It's prime. So you just stop at this point. You would only move forward if you had a square or a cube up here. Now, over here we have no GCF, and we can see that the exponent is 2, and the operator in between, the 64x squared and the 1, is a plus, so this is prime. In some books, they'll say not factorable.